You see the screen?
Yes, sir.
Okay. So is that we'll quantize scalar field. Okay. So yesterday we completed. So what about homeworks? Did you do it or no? What about homework?
নো স্যার করা হয়নি এখন
কেন কি হলো কি homework? If you don't do it, then it will be difficult for you to follow later. Okay. Anyway, so
আসছে না
কি আসছে না?
মানে যেটা প্রমাণ মানে আটকে যাচ্ছে
Best at the end of the class, show me where you are getting stuck. Okay, so complex scalar field, the Lagrangian density is half A is equal to 1 to 2 del mu phi A del mu minus half m square A is equal to 1 to 2. Okay, so basically I used a compact notation, and you know that if you write it explicitly, del mu phi 1 del mu phi 1 del mu phi 2 kinetic energy term, half I have taken already out. Okay, so m square phi 1 square plus phi 2 square. So this is my Lagrangian, and basically Lagrangian density. Now if we define, say, okay, so phi 1 are real scalar fields. Yesterday and say previous few days, basically not yesterday, a single real scalar field. Here we have two real scalar fields, and there is no interaction, okay, between the two real scalar complex scalar field. So it's basically free complex scalar field. Okay, so this is free complex scalar field, because if you look at this equation, del mu phi 1 minus m square phi 1, okay, and del mu del and del mu phi 2 m square phi 2 square, then you see this is like you have one dimensional harmonic oscillator square by 2m plus half kx square, and then if you go to the two-dimensional isotropic, the mass is same and the angular frequency is same, so you get px square by 2m plus x square minus half m omega square x square. This is one term, and the second term is half half m omega square y square. So similarly here you see that underlined with red, that constitute, underlined with the color blue, that constitute a second real scalar field del mu phi 2 term, which is product of phi 1 phi 2 or product of del mu phi 1 and phi 2. So there is no mixing completely. So basically this is two real massive scalar fields. Okay, we know scalar field. We'll be using the same technique to quantize this complex scalar field. Okay, you can do. You know how to quantize a single DL scalar field. So you quantize separately phi 1, you quantize separately phi 2. Whatever, for example, for harmonic oscillator, isotropic harmonic oscillator, you know for x degrees of freedom, this is n plus half h cut omega. You define one more quantum number m plus half h cut omega. Okay, so that's all, and then correspondingly you can write down the energy n plus m plus 1 h cut omega, and you can consider eigenfunction. On the other hand, you can do one more thing also. For the harmonic oscillator case, you can go to complex coordinate, that z is equal to x plus iy and z star is equal to x minus iy. In terms of z and z star, and solve the problem in terms of z. Okay. Here, what we will do is that we will define some complex scalar field as we define phi as 1 by root over 2 phi 1, that for complex for real x and y you define complex iy. Here I have done the same thing, phi 1 plus I phi 2, and for convenience I have used a normalization factor 1 by root over 2. If you prefer, there will not be any problem. Okay, now again this is a homework. This is a homework supplied to you, that this is very easy. Just like a coordinate transformation, you do y degrees of freedom, you want to write it in terms of z and z star. Similarly for the fields alone, and so you don't have to talk, okay, because this is transformation involving fields only. You can show that in terms of this, L can be written as del mu phi star minus m square mod phi square. Okay, so two real scale is equivalent to one single complex scalar field. Real scale. So again, I remind you, phi 1 and phi 2 are real. I is a complex scalar field. Okay. Now recall that for a single real scale, this kind of operator. Okay, so here for I should write down. Okay, so this is ak e to the power minus I k dot x a dagger k e to the power. Okay. Now think of, again, go back harmonic oscillator case. Suppose you have x degrees of freedom and y degrees of freedom. If you define the annihilation creation operator as a dagger, then for the y degrees of freedom, you have to define something new, not a and a dagger, b dagger. Okay. So similarly for the field phi 2, I write it as root over 2 pi cube 2k naught bk e to the power minus I k dot b dagger k e. Okay, clear? Now you know that these are the relations you are familiar with. তোমরা কি শুনলো?
হ্যাঁ স্যার।
Yes, sir.
হ্যাঁ, বলবে বলবে, কারণ যেহেতু মাঝে মধ্যে সমস্যা হয়, তো মাঝে মধ্যে একটু হু হু বলবে, এমনি শুনতে পাচ্ছি। So this we had already derived. AK, A K prime, A dagger K, A dagger K prime. Okay. Since B is independent annihilation creation operators, so it will have its own identical okay. Okay. Now, since I am talking two types of annihilation creation operators, so I know that all possible commutation relations involving A, possible commutation relations involving B and B dagger. Now the next question is that what about the mixed commutation relations, namely A with B or A dagger with B and B dagger? What about this? Since these are independent oscillator modes, as in quantum mechanics, all other commutators involving all involving A, B, A dagger. Vanish. Whenever you are struck with some ideas or some steps, what you have to do is two-dimensional isotropic harmonic oscillator. Whatever you do there, we are doing the same thing here. They are also, say for example, you define one A dagger A plus B dagger B plus half, one half from A dagger A, one half from B dagger B, and then you can why degrees of freedom are completely decoupled, there is no interaction between the two, you can derive these relations that A satisfies a set of, for the case of quantum mechanics, A dagger is equal to 1, A and all rest B, and any relation involving either A B or A B dagger or A dagger B or A dagger B dagger vanish. So far so good. কোনো প্রশ্ন? কোনো প্রশ্ন?
No, sir.
Okay. Now we substitute this expression for phi1 and the complex scalar field phi. So what we will get, আমি আগে লিখি, ওকে, তারপরে তোমাদের প্রশ্ন নিচ্ছি। dq k on to both phi1 and phi2 2 pi cube 2 k naught. So I'm taking then A plus IB by root over 2 e to the power minus ik dot x plus A dagger plus I root over B e to the power ikx. Simply this A, in order to save space and not to make it a clumsy expression, so I have not written the arguments of A and B, but in general, as you can see here, that A and B are function of k. Okay, so AK plus IBK by root over 2, A by root over 2. Is it obvious? এটা কি বোঝা যাচ্ছে? হ্যালো,
হ্যাঁ স্যার বুঝতে পারছি।
বেশ। So I define this as capital A, define this as capital B dagger. Okay. Now dagger x so 1 by root over 2 phi 1 minus I phi dagger x. Similarly, I take the common factor dqk 2k naught. Okay, A minus IB over 2. Again, let me remind you that both A and B are function of k. Okay, A dagger minus IB dagger root over 2 e to the power I k dot x. As in the previous case, এটা কত আগে যেটা করেছি তার সঙ্গে যদি সম্পর্ক রাখি তাহলে এটা কত হবে?
এ টাকা
হ্যাঁ,
এ টাকার হবে।
এ ড্যাগার হাউস
এ dagger কি করে হবে? B হবে। This is B dagger. So if you take a dagger, then A dagger becomes A, I becomes minus I, B dagger becomes, এটা কত হবে?
dagger.
Dagger. Okay. So you see this is consistent. Phi dagger, and with the definition of in the expression for phi dagger, there is consistent expression. Okay. So that dqk now I substitute for A. So A e to the power minus ik dot x ik dot x plus B dagger, and here I write dqk 2 pi k naught 2k naught B e to the power minus ik dot x A dagger e to the power ik dot x. Clear? Clear? Bolo hai ki na bolo? Okay. Now we know the commutation relations of small a. Now we have defined four operators, basically two operators, A and B and their adjoints, A dagger and B dagger, in their adjoints. So since we know the commutation relations of small a and small b's and their adjoints, we to find commutation relations satisfied by capital A dagger, capital B dagger. We do. So what we have identified is that A is equal to 1 by root over 2 A plus IB. A dagger shown 1 by root over 2 A dagger minus IB dagger. B as 1 by root over 2 A minus B. Don't get confused. I mean, B is A dagger because A and B, they are not Hermitian operators. A and B, they are non-Hermitian. So that's why A will change to A dagger, B will change to B dagger, and I will change to minus A. Okay. So A and B are really independent operators. And this follows B dagger. So 1 by root over 2 A dagger IB dagger. Clear? Clear? Hello?
Yes, sir.
So you want to study this one. AK A dagger K prime. This, best, if you want to study this relation, A we get 1 by root over 2 factor from A dagger. So we get half factor, then we get, now I should introduce the label, and now I should introduce the label. So AK so AK, capital AK is AK plus IBK, and A dagger K prime minus I B dagger K prime. প্রথমটার সঙ্গে প্রথমটার কি হবে? This with this কি হবে বলো?
Delta cube minus
Okay, delta cube K minus K prime. Okay. প্রথমটার সঙ্গে এইটা কি হবে? প্রথম এইটা, এটার সঙ্গে এইটা কি হবে?
0.
Okay. Now with this and this
0.
0. Now and this
Delta K minus K.
delta cube minus K prime, right? So now you understand why we introduced this normalization factor 1 by. So that means we get 2 into delta cube K minus K prime divided by, we get delta cube K minus K prime. If you prefer not to normalization factor 1 by root over 2, but say phi x is equal to phi 1 plus I phi 2. Then if you appropriately, then you will see that AK, that commutation relation will get some extra factor, some constant factor here in front of delta cube K minus K prime, but that is okay, that is not wrong. if we use the normalization factor, then what happens that our typical, I mean, since we have started learning annihilation, A dagger is equal to 1. Since here each A is dependent on K, so it's modified to delta cube K minus K prime. So there is no, okay, so that's why we use that particular normalization, but you are free not to use the normalization factor, but about this factor here, okay, some constant factor here, okay, clear? Now I will not do some of the commutation relations, since from your response I understand that you are able to do it. You can do it and show that bk b dagger k delta cube k minus k prime. দেখাতে পারবে তো, হ্যাঁ কি না? হ্যাঁ কি না?
হ্যাঁ স্যার।
So this is homework. Any computation involving A and B or their adjoints equal to 0. Just আমি একটা বলো কোনটা করব, or A B or A dagger B or A dagger B dagger, কোন একটা বলো করে দেখি। Anything suggest?
A dagger B.
Okay, so there is a suggestion that A dagger B. Okay, so what is A dagger? A dagger is 1 by root over 2 A dagger minus 5 B dagger, and B is 1 by root. Let me take again, there is 1 by root over 2 factor from both the terms, and A dagger is A dagger minus IB dagger K minus IB dagger K, and A dagger এর সঙ্গে কি করতে বলেছে? B. So A K prime minus IB K prime. Clear? Of this with this কি দেবে বলো? Minus delta cube K minus K prime. So this with this কি পাবো বলো?
0.
Okay, with this কত পাবো বলো?
0.
0. This with this কত পাবো বলো?
K prime.
হ্যাঁ বলো?
Sir,
হ্যাঁ সাইনটা বলো, সাইনটা তো সেটাই তুমি জানতে চাইছি।
প্লাস হচ্ছে তো স্যার।
আর একজনকে মাইনাস বললো যে somebody said minus sign.
স্যার বি ড্যাগার বিটা মাইনাস হবে, ক্যালকুলেশন করলে প্লাস আসবে।
Yes, so minus I into minus I, that is a minus sign. Okay, K prime is delta cube K minus K prime, but here you have the order B dagger K B K prime. Okay, so you get a minus sign here, so you get, so this is plus sign. যে মাইনাস বলে সে কি বুঝতে, আগে একজন মাইনাস বলেছিলে।
হ্যাঁ স্যার ঠিক আছে স্যার, আমি করেছিলাম আমি।
আচ্ছা বেশ। Now as you can see that this cancels out, equal to So apart from these two, apart from this A dagger K prime is equal to delta cube K minus K prime and BK B, you can check that all other commutators, all other vanish. So this is also homework. বাড়িতে check করে দেখবেন. Clear? No, বলো. Any question up to this? Any question up to this? বলো বলো তাড়াতাড়ি বলো, আছে কোনো প্রশ্ন আছে?
স্যার প্রথমে ওই সিস্টেমের ক্ষেত্রে আমি একটু লেটে ঢুকেছিলাম।
না দেখো দেখো
হ্যাঁ স্যার।
বেশ, বুঝতে পারছো কোন সিস্টেমের জন্য? ফিল করছি, লিনিয়ার হার্মোনিক অসিলেটর কোথায় পেলে? ফাই তো ফিল।
হ্যাঁ স্যার।
টু রিয়েল স্কেলার ফিল্ডস। ওকে, তুমি কোথায় ঢুকেছো আমি জানি না, যদি অনেক পরে ঢুকেছো জাস্ট বন্ধুদের কাছে দেখে নিও। ওকে,
আচ্ছা আচ্ছা ঠিক আছে।
বলছি এই যে কোয়ান্টাইজেশনটা করব, এটা মানে কি ধরনের ফিজিক্যাল সিস্টেমের ক্ষেত্রে এটা কাজে লাগবে? অ্যাপ্লিকেশন
চার্জড স্পিন জিরো পার্টিকলস।
ওকে, মানে ওটার কি ধরনের প্রপার্টি, মানে
কার প্রপার্টি?
চার্জ স্পিন জিরো পার্টিকেলের, মানে আগের থিওরিটা
ইনসাফিসিয়েন্ট ছিল না। হার্মোনিক অসিলেটর তুমি সলভ করো, at the same time you solve Coulomb problem. That does not mean that have two different problems. You solve harmonic oscillator problem, you solve this any other problem. So that does not mean that one of them is insufficient or something like that. Real scalar fields charge, electric charge, one can show that it has no electric charge. So if you want to describe chargeless particles, then right choice. If you want to describe charged particle, spin zero particle, then complex scalar. We don't stop it here. For this course I will not teach, but in general you can think of n such real scalar fields. Okay, interaction, there is no problem. So depending on the physical situation you will be using, and neither for the last lecture, last lecture, the real scalar field, nor for today's complex scalar field, we are not talking about any physical models so far. We are fields. Okay, the real physical scenario will come when we introduce interaction. How it interacts, either it can have star phi to the power 4. Okay, here if we introduce a phi star phi to the power 4, then we will get a self. It's a physical model, it arises in particle physics. Or we learn Maxwell field or the gauge field with this complex scalar field. So there will be interaction term. That's a physical thing. Pion interaction. Talking that real scalar field was insufficient to explain something, so that's why you are studying complex scalar field. Or again we will go field or vector field. Each field, as I explained in earlier lectures, please go back to the notes. Each field has its own properties. It's not that it is insufficient or something like that. Each field describes a particular type of particles. Real scalar Higgs particle. Okay, Higgs particle is also real scalar field. Okay, that is discovered 2012 or so, and I was not born that time when the idea of Higgs particle was given. Okay, real scalar field, charge scalar Of course, you cannot describe pion because pion you need pi plus, pi minus, pi 0. So you need more scalar fields. Okay. Pions, then you need to more real scalar field here. Okay. But this is also some scales, some particle you can describe. Okay. Anything else? Phi dagger checker, that is antiparticle, yes. If phi, if you identify is the complex conjugate field, so okay, so to be precise, I should not confuse you. This A is the particle annihilation of capital A is the particle annihilation operator, and A dagger is the particle. B is the antiparticle annihilation operator. Okay, and B dagger is the antiparticle creation operator. Understand that for real scalar field, phi was some expression in terms of A and A dagger. A was particle annihilation operator, creation operator. Okay, since it has no charge, so it's a self conjugate. Its own particle described by real scalar field is its own antiparticle. Okay, because it's a chargeless. There is no charge, no other charge. But here, in today's class only, we'll calculate this noether symmetry. There is a constant charge, and we'll quantize that charge, and we'll see that how to create that charge. Okay, that we'll do in today's class only. Now, with phi, we don't identify as antiparticle, because if you have followed my last lecture, then in a field theory, and we operate with appropriate creation operators to create particles. Okay, so here the new field is that I have two types of annihilation operators and creation operators: A, B, capital A, capital B, capital A dagger, capital. If you identify that A as the annihilation operator for particle and A dagger is the creation operator of B is the annihilation operator for antiparticle and B dagger is the annihilation operator for the creation particle. Now note that identify A as the particle creation annihilation operator. Therefore, there is a bit of convention. Say is a particle and positron, we identify it as an antiparticle of this nomenclature is not too rigid. If we have discovered positron earlier than electron, then probably we have called positron as particle and electron. That is true. Always it is true that electron is particle, positron is antiparticle, and also electron is antiparticle of positron. But there is a so that's why you can identify A as the particle annihilation operator or antiparticle annihilation operator. The convention that capital A is the particle annihilation operator, capital B is the antiparticle annihilation operator. বলো আর কিছু? হ্যালো হ্যালো
হ্যাঁ স্যার।
any other
স্যার বললেন যে ওই যে রিয়েল স্কেলার ফিল্ড আগের দিন যেটা করা হলো ওটা চার্জ পার্টিকেলের ফিল্ডকে মানে ডিফাইন করতে পারে না, তাই তো? মানে কেন, মানে এখানে ধরুন হচ্ছে দুটো পার্টিকেল রয়েছে, দুটো রিয়েল স্কেলার ফিল্ড, একটা পার্টিকেল একটা অ্যান্টিপার্টিকেল হচ্ছে চার্জের ফিল্ডকে ডিফাইন করছে, কিন্তু
again field is not particle antiparticle. Okay, phi is antiparticle, that's wrong. I'm not talking about that. I'm talking about that in the expression of phi, and similarly for phi dagger, annihilation creation operators. Okay, A annihilates particles as per our convention, and B annihilates and similarly A dagger creates a particle, B dagger creates an antiparticle. Okay, why do I say field cannot have any charge? Because just recall when I taught them, then I told you about two types of symmetries, space-time symmetries and internal symmetries. For space-time symmetries, you are all familiar with the concept quantities, right? So if you take the Poincare invariant energy momentum tensor, or basically energy momentum, and from the Lorentz transformation you get the boost and center of energy. These are the concept quantities. Now for charge, whether it is electric charge or Euler-Suess quantum number, all those are associated with some internal symmetry. Okay, just go back, I have written. So if you have to have internal symmetry, so that means at least you should have two real scalar symmetry. Internal symmetry means what? Some kind of rotation in the internal space. But if you have only one field, how do you define the rotation? 1 degree of freedom. Say a particle is moving on a line, straight line. Okay, one-dimensional problem. Talk about rotation there. But if you have a two-dimensional plane, at least, then you can talk about rotation. If you have, say, higher dimensional rotation, but at least you need two dimensions to define a rotation. Similarly, in the internal space also, if I need at least two fields. For the real scalar field, we had only one scalar field. So we had no internal symmetry there. Of course, some kind of scaling symmetry one can define in four space dimension, very specific. Act of homework, I don't remember, problem number 9 or 10 with scaling B. That is to the power 4 theory and 3 space 1 time dimensions. Yeah, scale transformation that is not allowed in any other dimension. Okay, but you cannot define a rotation in the internal space, and so if there is no symmetry, even if you can, there is no question of being invariant and having a conserved charge. So that's why I say that real scalar field cannot describe a charged particle. While studying Klein-Gordon equation, we got some expression for rho, and because it was not positive definite, but I mentioned that can be identified as rotation. And in that expression, maybe in the later part of today's class, when I do that, I'll show you if the field is equal to 0, so it cannot have any charge. Anything else?
No, sir.
We do. We want to get expression for the Hamiltonian. Okay, so follow the steps. I did it. So dqx Hamiltonian density, total Hamiltonian H. Now there are two scalar fields. Okay, so there are two scalar fields. So we'll have two momenta, pi 1 and pi 2, right? Because once you del phi 1 dot, that will give you pi 1, and then del L del phi 2 dot pi 2. Okay. Now I also I also define pi x as 1 by pi 1 plus pi 2, and it naturally follows that pi dagger x is because pi 1, you can look at the expression that pi 1 is by definition, by construction, is Hermitian, both pi 1. Then this pi 1 and only minus sign comes from minus sign. Okay. So Hamiltonian density, it will be pi a minus Lagrangian density. So Hamiltonian will be dqx. Okay. Not doing the steps, now you know how to do it. Half a is equal to pi a plus grad phi a dot grad phi a square phi a phi a. দাও এক মিনিট, এখানে একটু নোটেশনটা গুলিয়ে গেছে এইখানটায়, জাস্ট 1 minute. Okay, grad phi a grad phi. Let me remind you, for pi script, but for phi this subscript. Okay, because this quantification covariant notation, it comes like this. Okay, just 1 minute. Okay. Okay, now so this is the expression in terms of these, in terms of component. I have already defined capital pi, sorry, write it in terms of pi and pi dagger. Then you find that this is the expression pi dagger pi phi dagger grad phi. Okay, I am writing, although I am writing complex conjugate, so because it's a single scalar. Okay, now this part dqk ek by 2 a dagger k ak a dagger b dagger k bk okay. Now you can do these calculations in two ways. Say when I obtain this phi a grad phi dot grad phi a m square phi a, okay. আছো তোমরা আছো? হ্যালো হ্যালো
হ্যাঁ স্যার
Yes, sir.
okay.
হ্যাঁ স্যার,
So okay, so a is equal to 1. A is equal to 1. What do you get? You get pi 1 plus grad phi 1 dot grad phi 1 plus m square phi 1. How to express it in terms of a dagger a, that we did yesterday. Okay, for a is equal to 1, the summation a is equal to 1. two terms. Okay. Now similarly, you do it. আচ্ছা এইখানে একটা বোধহয় একটা so you do it for a is equal to 2. Now again for a is equal to 2, you get the same thing, but in terms of b, getting the same thing. I mean, whatever I did yesterday for the single scalar field, I am doing the same thing for the two real scalar. So all the expressions are just, you have to put the expressions and sum it up. That's all, nothing more than that. Clear? Is it clear? Clear. Okay. If it is clear, then also you can write this small b dagger. You can check it. These are simple algebra. These are simple algebra. Nothing very difficult. Now you can express it in terms of capital A, and you'll see কিন্তু তোমাদের এটা করতে হবে, না করলে কিন্তু খুব মুশকিল। কিন্তু হ্যাঁ, পরীক্ষা পাস হয়তো করে যাবে, কিন্তু শেখার জিনিস each and every day, if you do not work it out, at least try. খুব কঠিন নয় কিন্তু। A dagger K, and when you opted to learn a new thing, so it's better to give. It's a wastage of time for you also. Okay, simply an A dagger, B and B dagger in terms of capital A, capital B, capital A dagger, capital B dagger. You have this relation here. You have this relation A dagger, B. You have relation here, B dagger. Now you can invert this relation, right? How can you invert this relation? Say you just, if you add A and B, then you see that root over 2A সমান A plus B. দেখতে পাচ্ছ? হ্যালো, দেখতে পাচ্ছ মানে not the board. আমি কি মানে argument? Can you see through the argument? Okay. Similarly, you get for A and B, you can similarly get the expression for A dagger and B dagger, and then you substitute it in this expression, and simplify this expression. Okay, so again, although it looks very complicated expression, it's not really complicated, because this Hamiltonian, you have this expression, you write it in terms of component form, like pi 1 plus pi 2 dot grad phi 2 plus m square phi 1 plus m square phi 2. For each phi 1, you know, for dagger k for phi 1, and for phi 2, b dagger k bk, bk b dagger k, and there is a factor ek by 2 dqk. So I have done this. Between step is just to, I mean, you can of course, for this step, you can write directly, express it in terms of pi, and similarly all previous expressions you express in terms of capital. Whatever is your preference. Actually, if you want to go from here to here, the in between. Now this is your expression. Now what I do is that I use কি করলাম এটা hello,
normal ordering, sir.
yes, so normal ordering কি হয়, কি লিখবো বলো? dq k
ek,
dq k ek,
A dagger k ak,
A
স্যার
dagger
EK by 2 আছে একটা।
dagger के b के
plus b dagger k b k আর কিছু আছে?
স্যার কে বাই 2 আছে।
বেশ, যে আমাকে বলতে বললে, so let him answer that whether that by 2 factor will be there or not.
না স্যার থাক।
So explain it to your friend. কেন থাকবে না এক্সপ্লেন করো? Okay. So those who are feeling shy to ask the question, that when you do the normal ordering, and so normal ordered form is a dagger k a k. On the other hand, this term dagger k, when you do the normal ordering, you get a dagger k a k. Okay, so there are two a dagger k a k terms, so that one a dagger a k. Similarly, for b dagger bk and bk bk dagger, the first term is already not. The second term is not normal ordered form. If you do the normal ordering, then you get b dagger k bk. So there are two. There is a half factor, so it cancels out. So there is no half factor there. Okay. Now I define. Now this is like two types of oscillators. Again, each type of oscillators, there are infinitely many because of its depth. How do I define the vacuum? Just like yesterday's class, I define vacuum as sorry. What is step to liquid? I define vacuum as AK is equal to 0, BK 0 is equal to 0 for K. Okay. So this is very important, that when these two equations are simultaneous, then only we can identify 0 as vacuum. As I said, that A is the annihilation operator for the particle and B is the annihilation operator of the antiparticle. So both should be, otherwise it may happen that there are no, suppose if the first condition is valid, so that means that in the, but if the second particle is not valid, second condition is not valid, then it might happen that it is antiparticle. But vacuum means, as I said, no particle. If there is no particle, then there is no energy or there is no momentum or some other physical quantities like charge, speed. So both the conditions, this is the important part, both the conditions should be satisfied simultaneously. How do we create states? So K, A dagger K is a particle, K denotes a particle with linear momentum K, and you have to calculate the energy EK, because you now know how to calculate it following yesterday's lecture. And we create, this is not a vector sign, okay? Particle we are denoting by K and the antiparticle we are denoting by K tilde, okay? K tilde ki hobe bolo? Now you know. What should I write on the right hand side of the equation?
b dagger के 0
B dagger K 0. So this is particle, this is antiparticle. Okay. If you calculate, say you can Okay, say you define operator, then A dagger K AK plus B dagger K BK. This part is, again, you can divide it into two parts, say P NT AP. You call it NT particle, NT antiparticle. That means in the system, how many particles are there? Then basically we define particles are there. So if NT is measure of just either particle or antiparticle, total number of things, then you plus B dagger K BK. On the other hand, you may be interested to know how many particles are there. You are not interested in antiparticle. Okay. Similarly, you may be interested in I don't care how many particles are there. I'm interested in how many DQK, B dagger K, BK. That will give you how many antiparticles are there. Okay. Say, for example, we have already defined K tilde as B. Now, how many particles are there? How many particles are there in this state? Okay. So, in order to find that, what you will do, K A dagger K B dagger K prime 0 কত হবে বলো? In the tilde in the state K tilde বলো কি হবে? আমি এক্সপ্রেশন লিখে দিয়েছি। দাঁড়াও এক মিনিট, দাঁড়াও এখানে yes K. হ্যালো হ্যালো
হ্যাঁ
হ্যাঁ বলো, কে বললে বলো?
হ্যাঁ আমি অর্ণব বলছিলাম স্যার।
হ্যাঁ বেশ, এবার do all that this is equal to 0.
Yes.
Okay, so why it will be equal? One of might answer on based on common sense. The state is a single particle antiparticle state, so there should not be any particle. So that is okay, that's correct reasoning. But if I ask the mathematical explanation, or no, can you explain why mathematically this will give 0?
ভাবছি স্যার।
কি ধরেছি উত্তরটা তুমি common
হ্যাঁ
sense থেকে
হ্যাঁ
দিয়েছো?
কমন সেন্স থেকে দিয়েছি।
Okay, so
স্যার
can you
বলবো?
স্যার
হ্যাঁ বলো বলো বলো।
আর কে দুটো তো কমিউট করে, তো ওটাকে কমিউট করলে এই কেটা ডান দিকে চলে আসছে, ওটা
Yes.
জিরোর ওপর অপারেট
Yes,
করলে
you
কি
are.
হয়?
No, do you follow the argument?
ইয়েস স্যার।
So I can always write this one without changing anything equal to 0. Okay, so this way you try many things, you create states and many things, and there is no new technique. If you follow the real scalar field I talked yesterday, using that you can calculate the energy of this K tilde. Okay, will be K Ek, linear momentum will be K. Similarly, you can calculate, say for example কোথায় গেল, you can calculate the total number of if you apply the total number of this number operator, you get one operate only with the particle number operator, then you get one only. If you operate antiparticle number operator, you get, this is as simple as that. Okay, now you may also create like this. Okay, K tilde. Okay, so you might create states like this also. Physically এটা কি মানে করে বলো কেউ বলো
পার্টিকেল থাকছে স্টেট।
একটা পার্টিকেল থাকছে একটা অ্যান্টি পার্টিকেল থাকছে। ইয়েস, আই টেক ইট। বেশ, energy of this state, K tilde state, what will be the energy of this state? Calculation you can do, of course, calculation, but from intuition, can anyone tell me that what will be the energy of this state?
0 স্যার পার্টিকেলের যদি পজিটিভ এনার্জি থাকে অ্যান্টি পার্টিকেলের নেগেটিভ এনার্জি ধরতে পারি।
অ্যান্টিপার্টিকেল যে ফিল্ডের যে ইন্টারপ্রিটেশন করেছি সে ফিল্ডের
তখন নেগেটিভ মাস ধরেছিলাম তখন।
তার পজিটিভ, রাইট?
হ্যাঁ হ্যাঁ হ্যাঁ, ইকেটা 0, ইকে গ্রেটার দেন 0।
Both are positive we have taken, but we have taken in the opposite direction. One is moving in the forward direction, one is moving in the backward direction. Okay, otherwise the energy is positive, K0 is always positive. So
স্যার 2e কিন্তু কে হবে মানে মানে স্যার 2 ইন্টু ই কে বলছে।
বি ড্যাগার K0 ওই স্টেটটার এনার্জি কত? আচ্ছা দাঁড়াও, ইয়েস দাঁড়াও, এক মিনিট দাঁড়াও, এখানে আমি কয়েকটা ভুল করেছি। এখানে ভুল করে এখানে একটা সিম্বল, একটা okay, so this means this linear momentum K, but it's antiparticle, so K tilde sign is for antiparticle. হ্যাঁ বলো, এবার কি বলছিলে বলো বলো তাড়াতাড়ি বলো, কেউ কি সেটা বলছিলে?
সেরকম স্যার এনার্জিটা মানে যেটা অ্যাক্টার হবে তার দিক।
এটা
হ্যাঁ স্যার।
এই তারপরেরটা এটা
এটা 0 হবে।
এটা 0 হবে কেন?
স্যার
আমি জানি না, আমি তোমাকে জিজ্ঞেস করছি।
স্যার মনে দিকে থাকবে না হয়তো,
ম্যাগনিটিউড একই, ডিরেকশন আলাদা।
একটু ক্যালকুলেট করে দেখবে নাকি সময় হবে না এখন?
আপনি করুন স্যার।
এই করবে কি তোমরা খাতায় বসে?
হ্যাঁ স্যার।
করো।
বুঝতে পারছি না করতে।
হ্যাঁ কিছু বলো।
না স্যার করে দেখতে হবে, বুঝতে পারছি না।
স্যার একটু হিন্ট দিন, কোথা থেকে শুরু করব?
তো করলাম, ওই মেথড কি ফলো করো। We did it yesterday, right? We calculated EK, we calculated method, except for the fact that now you have two types of annihilation creation operators. Otherwise, there is no different. Okay, you don't need any input. You don't need any input. And any input means any new input. If you want to calculate E, if you want to calculate E, then dq k prime ek a अगर k prime ak prime bk prime. This is the Hamiltonian acting on the state. Now you have to evaluate this, and I told you that means পড়াটা একদমই দেখছো না. Transition operator to the right so that it acts on the vacuum and gives you zero. So you get a simplification. Okay? Is not is equal to E, but so this is H K tilde. ঘরে যখন করছো না এখানেই করো, আর কি করা যাবে, করো। হ্যালো হ্যালো
হ্যাঁ স্যার।
হ্যাঁ করো করো, কালকে শিখিয়েছি, করো। কে বলছো এটা? সুমন? আর কেউ পেয়েছো 2e নাকি পাওনি? হ্যালো, 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 হ্যালো।
হ্যাঁ স্যার, করছি।
ওকে, যারা পারোনি তারা দেখে নি। ওকে, আমার একটা কারোর হয়েছে? Okay, you do the homework for K, this momentum operator K, and now let me continue because I have roughly 40 minutes and I have to finish one more thing. Okay, we define charge operator. Okay, now let me write it down again that lambda is del mu phi star minus m square phi star phi. Now I of this form phi goes to phi prime is equal to e to the power minus I. Okay, so phi x goes to phi prime x power minus I cube theta I cube theta phi x, so that phi dagger goes to phi prime dagger is equal to e to the power I phi dagger x. Okay. Theta is theta is independent. Okay. And there is no need to introduce Q here, but in future, keeping in that, we are writing Q and theta, both are constant here. If you prefer, you can write simply e to the power minus I theta x, and for the conjugate, e to the power I theta x. Okay. Now, global U1. Now, local U1 rotation is defined when theta is not constant. Theta is okay. Then this is called a local U1 rotation, but this we keep it for future. Today we that global U1 rotation or theta is constant. Now just see that lambda to lambda prime, then you had del mu phi prime del minus m square phi prime star phi prime. Now goes to del mu phi prime. Note this is internal transformation, internal symmetry. So that's why there is no change in the coordinates, only free. সমান কত del mu e to the power phi x to, since theta is constant, q is constant, so e to the power I cube theta del mu phi x. Okay. Similarly, del mu phi star or dagger goes to del mu phi prime star is equal to del mu e to the power I q theta phi star x e to the power I q theta del mu phi star x. And phi star phi goes to phi prime is equal to phi star phi. Bolo, is this okay? Hello?
হ্যাঁ স্যার
Yes, sir.
Internal symmetry, there is no change in the space-time coordinate, only fields. So that's what I am doing here, or like, or the calculation after that. Now, del mu phi prime from here, we see that it goes like power minus I q theta del mu phi x into del mu phi prime star x. From the next line, we see that it goes like e to the power I q theta del mu phi star x minus m square phi star phi. Okay. Since theta and q are constant, so this is del mu phi x. এখানে একটা ভুল আছে নোটেশনে। Okay, so we see that under this transformation, global U1 rotation, where phi goes to phi prime is equal to e to the power minus iq theta phi x, where q and theta are constants. This is a phase rotation. Then we see that lambda and lambda prime, they are in, lambda is remain invariant. Similarly for the action. Okay. Now this transformation equivalently means that is also including the homework, and I told you to do it repeatedly. I don't know whether you have done it or not. This transformation just try to understand as phi 1, phi 2, phi 1 prime, phi 2 prime. Okay. Minus sin theta, cos theta, phi 1, phi 2. আচ্ছা আমি এখানে এই ট্রান্সফরমেশনটা লিখলাম, তার ফলে I just this q here. I mean, it does not matter. Okay. So this phase rotation, why do we call it phase rotation? It is clear from this that scalar field phi can also be thought of as two real scalar fields phi 1, phi 2, and this transformation that phi x is equal to e to the power minus I theta phi x is equivalent to rotation in the internal space phi 1 and phi 2. So for example, if you write it as phi prime is phi 2, okay, then you can see we can write it as phi 1 prime phi 1 minus sin theta phi 2, phi 2 prime is sin theta phi 1 plus cos theta now phi prime is 1 by root over plus I phi 2 prime. Okay. 1 by root over 2 by root over 2 cos theta plus I sin theta. Okay, so to make connection with this, I considered this transformation minus sin theta, this. Okay, so phi 1 is cos theta I sin theta cos theta minus I sin theta phi 1 হ্যালো আছো?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
বেশ, দাঁড়াও। একটু just that was correct expression, but I just want to write it in more compact form. So cos theta minus I sin theta phi 1 এটা কি দেখতে পাচ্ছ? phi 1 prime, phi prime, so 1 by root over 2 phi 1 prime plus I phi 2 prime. So I am adding phi 1 prime here to phi 2 prime here. Okay, so I'm adding these two. So the coefficient of phi 1 is, so this is there phi 1, and the coefficient of phi 2 is sin theta plus, okay, so sin theta plus I cos theta. So again I phi 2 cos theta, that is the expression. So you get e to the power minus I theta phi. দেখো এটা বুঝতে পারলে? হ্যালো,
হ্যাঁ স্যার, বুঝতে পেরেছি।
বাকিদের কি অবস্থা? আদার্স?
হ্যাঁ স্যার, ঠিক আছে।
So you understand this is why it is called internal symmetry, because you identify this matrix as rotation, but rotation is in the internal space, in the space of fields, not in the coordinates. And if you write in terms of real scalar field, then convert it to complex scalar field, then whatever I had written it here, the E1 phase rotation, okay, so both are identical. So you see that you are by an angle theta, and you see that the action of the Lagrangian is invariant under this rotation. This is a continuous transformation because rotation is a continuous transformation. So as per Noether theorem, there will be a conserved the form of Noether 4 vector. Form of Noether 4 vector is when there is no space-time symmetry, then this is the expression. Do you recognize this? Hello?
Yes, sir.
Okay, so if you recognize this, then in order to calculate the Noether charge for this particular case, and delta phi star. So how do we calculate delta phi and delta phi? First এইটাকে বের করে নিই, তারপর ডেল্টা ফাইটা পরে বসাচ্ছি। ডেল এল ডেল মিউ ফাই ইজ ইকুয়াল টু কত? হোয়াট ইজ
ডেল মিউ ফাই স্টার।
ডেল মিউটা কোভ্যারিয়েন্ট না কন্ট্রাভ্যারিয়েন্ট?
কোনটা
So del mu phi star delta phi. What about the second term? Second term একটা ভুল লিখেছি, এখানে phi star থাকে। Second term
স্যার ডেল মিউ ফাই ডেল্টা ফাই স্টার।
del mu phi delta phi star. Okay. Now delta phi সমান phi prime x minus phi x. Okay. So phi prime x সমান 1 minus I theta y minus plus order of theta square phi x minus phi x. The first term is phi prime x. We expand the series 1 minus I theta plus I minus theta whole square by factorial 2. This way it will go on. Leading order term and neglecting theta square and higher order terms, because this delta phi means that infinitesimal due to infinitesimal variation, the transformation, we are treating theta as a small parameter. If you treat theta as a small parameter, because you get the identity transformation, phi goes to phi prime is equal to phi. So if we keep theta small, that means identity transformation. So if theta is small, we can neglect all higher order terms. Okay. So this means phi x minus I theta phi x plus order of theta square a phi x কেটে গেল, so phi x. Similarly, delta phi star will be I theta phi star. J mu সমান del mu phi star delta phi is minus theta phi x. Okay. That my continuity equation is del mu J mu is equal to 0. Okay. So in the definition of J mu, some arbitrary constant, still that will be a conserved quantity, right? Say del mu J mu is equal to 0. Then suppose 13 J mu, that will also satisfy the same equation. Del mu of 13 J mu is equal to 0. Or say 420 J mu. So del mu of 420 J mu is equal to 0. Or some co into J mu, del mu of co into J mu is equal to 0. So since theta is a variation parameter, okay, it's constant, it does not have a physical significance, and the conserved quantity should be valid for any theta. So in this আচ্ছা এখানে রাখি, পরে না বাদ দেব। তো বেশ, এটা গেল প্লাস e to the power phi theta x। তার মানে কি দাঁড়ালো বলো জিনিসটা? I theta phi star x del mu phi del mu phi star x. Okay. Now if J mu, then this is also constant quantity. Okay. Because then this becomes a real valued. Okay. The right hand side becomes real valued. if j mu by I theta is also constant quantity. If I take the I just like theta here, then right hand side that is also constant quantity, but the right complex valued. Or in other words, when phi will be promoted to operator, field operator, then it will be non-Hermitian quantity, but we don't. That will give me complex eigenvalues. So that's why I'm keeping I, but theta is the small angle, and my invariance of the action should be valid for any arbitrary angle. So that's why theta is relevant here. And as you can see, if del mu j mu is equal to 0, then del mu of j mu by theta is equal to also 0. So basically, in the definition of expression of j mu, in the expression of j mu, I can simply throw out theta and write j mu, okay, I phi star del mu phi minus phi del mu phi star. Can you recognize this form? এটা কি চেনা চেনা লাগছে?
স্যার এটা কারেন্ট ডেন্সিটি মানে প্রবাহ
4 ভেক্টর যেটা ছিল, probability current density ছিল যখন v is equal to 0 and for v not is equal to I, probability current, right? Now when we learned about Klein-Gordon equation, I mentioned that when Klein-Gordon equation was not successful enough to describe the relativistic quantum mechanics, then people discarded it and Dirac equation and all this. But Pauli and Vaishkov is also very famous physicist. They told that, okay, I mean, since this can be interpreted as charge density, okay, because charge density can be negative, probability density cannot be negative, but charge density can be negative. So basically, Klein-Gordon equation, and we are getting the same current. We got the current here earlier also, but here this conserved current is coming because of this relation, that action of the Lagrangian is invariant under this U1 global rotation. Okay, so this is the Noether charge. Clear? So this is the expression for Noether charge, total charge, dqx j0 means I dqx phi star minus phi dot star. Okay, classical charge, Noether charge, but we are doing quantum field theory, so we have to calculate what is the expression. Okay, now again this part is homework. I have taught you the relevant techniques. Now that means this is in terms of field. You express phi in terms of ak to the power minus ikx, bk to the power ikx, and all this blah blah. You take derivative here and then substitute in this expression, and you perform the integration. The way we obtain the Hamiltonian density of the total Hamiltonian for the real scalar field. If we do this, then this is again a homework. You can show that normalize a normal ordered charge operator has this form, dqk k dagger k ak okay, besh clear? Hello,
হ্যাঁ স্যার
anybody else? বাকিটা ঠিক আছো? Hello,
হ্যাঁ স্যার।
হ্যাঁ স্যার।
okay, this is my charge operator. Okay, this is classical charge. Okay, this is charge operator. So acting on some state, it will give me the eigenvalue of that state and tell me what is the charge of that particular state. Say for example, now again I am now not using this normal ordered form. So Q0 মানে কত? Q মানে তোমার এই যে এক্সপ্রেশন আছে dqk a dagger k ak b dagger k bk 0. What is the expression?
জিরোই হবে স্যার।
0 স্যার।
Why?
তো এটা জিরোর উপর অ্যাক্ট করলে জিরো দেবে, বিটাও জিরোর উপর অ্যাক্ট করলে।
Okay, so this is equal to 0. So vacuum, it has no particle, it has, and consequently it has no energy, no linear momentum. For the complex scalar field, one more measurable physical quantity is the charge of the state. And we see that vacuum has no electric, no other charge. We should not identify it as electric charge. Depending on the situation, it could be electric charge or baryon number or electron number. So it has no charge. What is the charge of this state?
সেকেন্ড পার্টটা জিরো হবে, বি ডাগারের যে পার্টটা, প্রথম পার্টটায় করলে এ আর এ ডাগার কমিউটেশন করলে ওখানে ডেল কিউব কে মাইনাস কে কে ড্যাশ আসবে।
ফাইনালি কত এলো?
করে বলছি স্যার একটু।
হ্যাঁ, কর কর।
স্যার শুধু কে স্টেট আছে।
তার মানে কি আইগেন ভ্যালুটা কি হলো?
1 স্যার।
1.
Okay, say when I think out this theta or q term, I was writing a q term, I've thrown it out. If I have kept it theta or q term, then it meant then it will transfer. I threw out q and q, so that means I'm working in a unit where charge k is equal to k means the state k has unique charge, unit positive charge. Okay, similarly, since now home, you will see that it has eigenvalue minus t3. Okay, so that means state k has positive charge 1, tilde has negative charge minus 1. So that's why from the beginning I was talking about this construct, a particle and k tilde Now it is obvious that you see that from just in front of you, I identified the Noether symmetry and then obtained an charge and then charge operator, and I am acting on the states k and k tilde by the charge operator, and I see that for the one, on the other hand, for the charge operator acting on k tilde, it has the eigenvalue -1. So that means it has charge and k tilde state has charge of -1 unit. So that's why this is a state particle state, and that's, and also I should mention that apart from this charge, all other physical and energy, they are same for both k and k state. Okay, so that's why these are anti, that their energies are different, but still they have one of the state is having +1 unit of charge and another - unit of charge. We cannot identify them as antiparticle pair. We are identifying here k as particle and k tilde as antiparticle because of the reason they have the same energy, they have the same linear momenta, only charge is different. Okay, and exactly opposite. So that's why we are identifying it as কি বলে ওটাকে পার্টিকেল অ্যান্টিপার্টিকেল পেয়ার। এইটা যখন পেরেছো অনেকে এটা দেখতেও পারবে, এই যে স্টেটটা আছে এর উপরে যদি কিউ অ্যাক্ট করো তাহলে পাবে 0। কেন 0 পাবে? তার কারণ দিস স্টেট মিন্স one particle one antiparticle, you are operating with a charge operator. So what happens? Particle and one antiparticle, particle has unit charge and antiparticle has -1 charge. So for the system, electron positron pair, electron has a charge, positron has the charge exactly opposite to the electron. So for the system, net charge is equal to 0. So you will get this. Okay, clear? I stop it here. You have a class. I have 4 minutes. So if you have any question, I can take it, or next class, because other teacher will be waiting for you. কার আছে? বিকাশের ক্লাস আছে নাকি? বিকাশের ক্লাস আছে? বেশ, ঠিক আছে। If you have any question, fine, because it's already 3:26, or you can just leave and ask me in my next lecture, whatever you prefer. না বলো। বেশ, if you have no question, it's okay. কিন্তু অ্যাটেন্ডেন্স খুব পুয়ার, তো সেইটা কিন্তু আমি জানি না, তারা যদি ছেড়ে দিয়েছে সাবজেক্ট ফাইন, আদারওয়াইজ তোমার তো হ্যাঁ হ্যালো
হ্যাঁ স্যার, মনে হয় 16 জন।
হ্যাঁ 16 জন, কিন্তু চেক করেছি 10 জন ছিল, লোয়েস্ট ছিল আজকে 8 জন, মানে একটা সময় কোন একটা পার্টের সময় ছিল। তো এইটা কিন্তু ওকে বাই, অন্য ক্লাসে যাও, টিচার অপেক্ষা করবে, তোমরা ক্লাসরুম থেকে বেরো, তারপর আমি সবার শেষে বেরোবো।